to go ahead and get started. It looks like we have a pretty good audience here today with about half of you already in production with Kubernetes and half of you working on it. Oh boy, let's stop that. There we go. So I'm going to go ahead and introduce our speaker. I think today's topic is very important because I was recently at KubeCon just last week, and the day before KubeCon was DevSecOps Day, where people were, a bunch of security professionals were able to come together. And the question was asked of this huge audience of people running Kubernetes in production, how many of you are doing image scanning today? And the shocking thing was that very, very few people were already doing it, even though I think it's one of the easiest things you can implement. Jeremy, I want you to go ahead and start sharing your screen while I finish introducing you here. So it's a topic that is one that we've talked a little bit about before, but it's one that I think is still sort of reverberating throughout the industry. People need to understand how valuable it is. I do want to introduce our special guest speaker, Jeremy Balance, coming to us from Anchore, which is a container security company. We really appreciate him coming and putting together this content for us to share a little bit about security. So Jeremy, feel free to introduce yourself further and take it away.
Yeah, thanks, Dan. Hey, everyone. My name is Jeremy Balance. I'm a solutions architect at Anchore. And primarily, I'm going to be talking about container image scanning with Anchore in Codefresh pipelines. So in terms of quick agenda, I'm going to be going over a little bit about container security and the model we take and what we like to actually describe as a good approach at Anchore. Secondly, I'm just going to be talking a little bit more about Anchore in a Codefresh pipeline, show a little bit of an example within the actual Codefresh UI. If there's some time, I'll show something within the Anchore UI, although I think we may run out, and then leave the very end for Q&A. So container security and really what should a container security model look like? And ideally, we'd like to have it involve securing all pieces in the container lifecycle, right? Anchore is responsible for a piece of this aspect, but it's really important to, when we're figuring out how to actually implement containers into production and getting to work with Docker files and images and registries, that there are many different aspects of it. And primarily, Anchore is focused on the image scanning piece of things. So we really think this should be a mandatory step in a CI/CD process. So that being said, oftentimes this goes hand in hand with shifting left, just a general philosophy to catch vulnerabilities early in the development lifecycle. Most commonly, developers are writing code, committing code, adding libraries. I mean, this kicks off a CI/CD process, right? And there's testing involved, and Anchore should be, or any image scanning should be one piece of this, right? We're going to actually conduct a deep analysis on the image, which I'll get into in a second. And then a result of that, there'll be typical policy evaluations that get evaluated over the analyzed image data. So kind of diving in a little bit deeper, why do we need to scan images? Container images are greatly increasing the speed of development and release, right? Now that we have these new artifacts that we're able to iterate on faster in terms of development, there's a lot more that can end up in a registry and more kind of importantly, a production registry, right? And these images can then be instantiated into containers in production environments. In short, though, images are these archive files that contain a file system and all of these components that are necessary to run a given app or a microservice. And these particular open source components and libraries, both the operating system and non-operating system, can contain vulnerabilities. So if these vulnerabilities aren't scanned, again, depending on how we've set up in terms of pushing to registries, in terms of pushing to image repositories, these can, again, make their way into environments that need to be more secure. Additionally to that, right, we've been talking about, okay, there are these packages, these libraries, these components within the image, but there are also other things that we can add to a container image. Developers can leave secrets or credentials. There's a lot of image metadata as well, right? The image size plays a pretty critical role. in a lot of things in terms of best practices. For example, we want to make sure we're developing small images if we can. And Docker files also contain sensitive information, right? In terms of how the container is actually run, right? If we're exposing unnecessary ports or saying you can run this container as a root user, that's something that as we're scanning these image artifacts, we want to make sure that we're also looking for at the same time. And in terms of what does image scanning actually do? So in the case of Anchore, the tools are inspecting these images in a deep and kind of broad way and generating a manifest of the image, right? And we like to think of it as just creating a bill of materials that not only includes the operating system packages, the unofficial packages, any type of non-operating system packages, but also information about the image, what's in the manifest, right? Configuration files, again, those secrets that I mentioned. These are all things that the tools are going in and making categorizations on, and eventually, as policies get evaluated over that analyzed data, potential decisions. Policies themselves are usually pretty standard to an image scanning tool or any type of tool that's kind of adding to the DevSecOps pipeline. And really what we're thinking about is, okay, let's create some governance around what we're finding. Security vulnerabilities, any of the data we're extracting and analyzing from this image artifact, want to make sure we have full flexibility and the freedom to create policies around this, right? It's not just enough to find out what's in there. We want to make sure that we have the option to either control whether or not the particular image will progress into the next stage in our pipeline. And kind of to sum that up, image scanning is just, we want to know what's inside the image, right? Images, again, this is this kind of black box sometimes. Sometimes we don't know what's in the image. And the focus for image scanning and image scanners that we've seen is not on the proprietary source code or the dependency analysis, which is certainly a little bit further left, those two aspects of it. But again, understanding the contents, what's in there, and let's make some decisions on it to help us with governance. So diving into a little bit about the Anchore policies, because this is what I'm going to primarily focus on when I dive into the live demo, is first and foremost, we're going to conduct this analysis on the container image. And following that, there's actually two applications that run over all of this analyzed data. The first is, okay, we have this manifest, this bill of materials. What are the vulnerabilities, right? Give me that. That's pretty standard and pretty easy to do. The second aspect of it is, okay, let me conduct this policy evaluation over it. And as we've been talking about, these are the user-defined rules, right? And these are some of the rules that can be created. Anchore is very API driven, so they can be created through the API, the CLI, and we do have a UI client you can also generate policies through. And the primary thing at the bottom is the enforcement aspect of it. So for this case, since we are talking about Codefresh, I want to focus on CI/CD. But Anchore can also be set up to run as a sidecar. So if we did have a registry, maybe a Codefresh registry that I've authenticated with on the Anchore side, as I'm pushing image updates to that, Anchore can be set to watch that. So if there's a new update to a tag, for example, and there's a new digest, that may contain some differences between those two manifests. We want to make sure that we're at least understanding what the differences are, and we have the appropriate tooling in place to actually let us know that there's been a change to there and to rescan. And this is an example of a policy. Policies themselves are self-contained JSON documents, and there are sets of these rules, right? And this is the one I'm just going to be focusing on. This is pretty standard stuff, but things that should be, able to be looked for in an image. And really what we're saying is, okay, look in the Docker file, look for port 22, and we don't want to allow that to progress through, right? We want to say, okay, if we find this in the Docker file with the associated image, let's make sure that we're putting up a stop action in our CI/CD because for whatever reason, we don't want to allow this through. Maybe it's an internal organizational thing, or maybe we just know that port 22 is not something we want to be exposed. So in terms of scanning with Anchore in a Codefresh pipeline, I'm going to be going through the Codefresh YAML file. the first step is going to build from a Docker file and automatically push to that Codefresh registry. The second step is going to actually analyze the image and evaluate those policy rules. And the final step, which is dependent on the result of the policy eval, will push the image to Docker Hub. So we're kind of using the Codefresh registry as a, I could say maybe a dev or a staging registry. I think the really nice thing, and I'll dive into it in the codefresh.yaml file, is right after we have this build step, we're automatically pushing to this Codefresh registry. I don't have to add another step to do that. Then how do I use it? I'm going to be talking through all of this stuff. There's an open source piece of Anchore, there's an enterprise piece of Anchore, and I'm going to be actually toggling through the two different GitHub examples and showing the differences in the images. So I just wanted to quickly jump to this repository I have right here, which says node critical fail. So this is just a Docker file essentially. And within here, I kind of wanted to outline some things that developers can do by accident, right? As we're giving developers more freedom to create their own images, these things are a virtual certainty. And one of them is what I was mentioning in that policy, which is expose 22. And there's a dev note in here. It says, remember to re-enable health check. So health check is a best practice that should be kind of enabled at all times. I don't have it kind of set up in a policy right now, but usually you'd want to maybe create some type of warning action if there's no health check within the Docker file. But it says, remember to re-enable health check and remove debugging port 22 before the final push. So if developers don't do this, and we do have these policies set up, it's going to actually fail. Similar to that, I have this node critical pass. And this looks like the developer followed the rules in this case. And there are actually re-enabling the health check and removing port 22 for debugging. I did just kind of want to highlight this because this is not specific to the packages that get brought in. This is not specific to just a flat out list based on vulnerabilities and it's high or medium. That's all, I think, pretty standard across image scanners, but these particular checks are equally important when we start to think about how we're going to develop these container images and how we're going to work with them. There's far more than just that inventory and bill of materials of the packages themselves. So for this one that's going to pass, and the HTML files are virtually similar. But this is the configuration file for Codefresh. This is actually going to define how the build is going to run. And as I mentioned, the first step we're going to say is, okay, build the Docker image. And then following that, we're actually going to scan it with Anchore. And then following that, we're going to push the image. So something to note, you can see this Anchore Engine CLI right here. That's actually a container that comes up during the scan. And I'm passing environment variables to it, and I'll actually jump to Codefresh to show that. There are environment variables that I set up here, and really what we're looking for is, okay, is there a running Anchore Engine service? There's just a standard kind of admin foobar username and password that I'm passing to it as well. But the thought is that you're going to be scanning these images consistently and continuously throughout your CI/CD process. So you're going to want to be hitting it in Anchore Engine service as well. So that's this environment variable piece of this. And this has been triggered on any type of Git commit. And just to show what this passing one looks like, I just want to say, okay, this makes sense. We're cloning, we're building. Following that, we're actually going to be scanning the image with Anchore. We pull down that latest engine CLI, which is used to communicate with that running Anchore Engine service. And then we do some scripting in here. The analysis gets done. We wait for it to complete. And once it's analyzed, actually successfully runs this step. It's been passed. And we move on to saying, okay, good, it did not fail, and we are going to push it to Docker Hub. And the opposite one of that is going to be because of those checks we have in place, and because we left port 22 within that Docker file and we built that image to say so, we're actually going to see it fail at the third step. And really it's because of this status of fail. What's kind of most commonly used in terms of working with these fail types of analysis and whatnot is the user interface portion of Anchor. So there you're able to immediately see, okay, well here this particular image got scanned, got analyzed, and then it failed based on the result of the policy evaluations. Here's everything detailed out as to why. All of that information is also accessible via the API as well. Just a little kind of tiny bit of background on Anchor. Very API first, right? When I talk about the UI portion of things, that's a newer feature in terms of enterprise. But we really wanted to make the API granular and really able to be used in a variety of different ways, not just for CI integrations, but any type of product integration that you want to leverage image scanning with. I want to just show at least some of where the images get pushed in Codefresh. What I'm doing right here is just using the Codefresh registry, and I've added just a quick annotation that says pending Anchor scan. But this is pretty interesting too, in that this is a step that with the codefresh.yaml file, I don't necessarily have to worry about, okay, do I want to push this to Docker Hub and then pull it back down with an image scanner, and then I have to worry about some of those things. Whereas automatically within here, I know it's in a container registry. I'm authenticated with it and I can communicate with it. And then following that, if I'm using, in this case, Docker Hub is maybe one of my primary registries, I know it's passed the Anchor scans when it's made its way into there. So one super quick thing I wanted to show as well. Looks like we have some time. Back over here, I kind of glazed over it, so I wanted to go back. Is really being able to see just some of the scripting that we're doing here. It's pretty standard, but this CLI command is really just saying, okay, go ahead and pull down this image. They're actually fetching it with a tool called Scopio and conducting the analysis on it. And as I've mentioned, what we're doing is going through and really trying to uncover the contents of that image and then saving that analyzed data itself. So this is something that also really helps in terms of the concept of immutability, right? These layers are going to be immutable, the image is going to be immutable. So really, we should only have to scan this particular image digest one single time. Following that, there should be no changes to this particular artifact. So if we save that data, which kind of runs behind Anchor, in this case, there's just a Postgres DB container supporting it. We can run any other type of analysis in terms of the policy evals, in terms of the vulnerability applications over that analyzed data. And we don't have to wait for a fetch and a pull back down, a rescan and creation of the entire file system. And when you start to think about scalability and, if we want an image scanner that's going to be highly available and able to be a distributed system and act as such, being able to have that kind of core piece of architectural design ends up playing a pretty big factor. And I did also want to show this aspect of things as well. So I've been talking about the Anchor policies themselves. And this is, I think, really what primarily creates a difference as well. So if we're thinking about image scanning and creating a security posture that's going to be going to be better as we're automatically scanning images, increasing the whole security landscape of things with container images. We want to make sure that all of those checks that we're able to at least uncover are able to be easily configurable. So any one of these policy bundles themselves can just be dropped into Anchore, and then in your Codefresh pipeline, just run that evaluation against the specific policy bundle. And I just wanted to give a quick sense of what some of the gates we have are. The standard stuff is vulnerabilities in terms of kind of general secrets, any other type of metadata you're able to extract. So things like that image size I mentioned. If we want to make sure we're only kind of grabbing base images and whatnot from a certain set that we have, we can navigate to this particular gate and maybe we want to say a Docker file instruction from, or that health check instruction. So this kind of adds to that aspect of, okay, we have organizations who have compliance needs and they need that governance. They need to have some control over the images moving through their pipeline. And this is really just a good representation of the image data you can extract and the control you can create based on the flexibility of the policy engine itself. So yeah, jumping back to kind of the how to use things, I went through those two image examples in terms of the fail and the pass. I did just want to mention as well, kind of outside the scope of this conversation, but in particular to Anchore, and the engine lives in here. This is just the general GitHub repo for it. It is available via Helm as well. Right within here. So if I did have a cluster, I could just spin it up via Helm very quickly within Codefresh. And then last piece I wanted to make sure to mention, I've been talking about some of the things in relation to, in relation to the UI, in relation to the enterprise piece of thing and those bits. That is something that's outside of the open source offering, but certainly available through Anchore. So it's just that anchore.com/enterprise. And that is licensed through just the number of images essentially you're scanning. We base it off image repositories. If you can think about how Docker Hub structures it, it's registry, repository, tag. So it's just that middle count. N number of registries, you can have any number of tags within those particular, well, N number of repositories, and you can have any number of tags within those repositories. So yeah, kind of a decent summary to that. Really what we just want to make sure, at least that we're covering in this aspect of it, is that the container images should be scanned. This should be mandatory as part of a CI/CD process. And these policies should be created and enforced at the CI/CD layer to increase confidence in deployments. So we've been focusing mainly on this image scanning aspect of things, but it's really a small piece of actually finding all of the vulnerabilities that actually might exist throughout the container lifecycle, right? We have the runtime, which is equally important. It's oftentimes a pretty long piece in the container's lifecycle. So we want to make sure that we have the tooling in place to monitor and agents to actually watch those particular hosts that Docker is on and the containers that are running on those hosts. And then of course, actually how Docker is configured on that host as well. There are a certain number of checks that should be done to make sure the Docker daemon is configured appropriately, and those folks who have the right permissions to access and spin up containers and spin them down are kind of aligned appropriately. So yeah, that's about all I had to share in terms of Anchore. I did want to kind of keep it open to, I know there's a decent amount of kind of image scanning tools out there, and I certainly want to make sure I answer any questions specific to those or anything specific to Codefresh and Anchore in general.
Thank you very much, Jeremy. Really appreciate you giving that presentation. We have a few questions. Just a reminder for those that are still with us, we are going to be publishing this video as well as the slides and all of the relevant links to our blog today. You'll get that as a follow-up for attending. And the step that you shared, the image scanning step, was approved for the Codefresh marketplace. And so I know that it's going to be available in our plugin directory probably today. So everybody can look for that. Feel free to use that Q&A button to ask questions. And I'll go ahead and moderate just a few of those. And while we're taking some questions, I do have one additional poll just to ask for feedback on how this webinar was. We really appreciate you letting us know and giving us good feedback on that. So first question, Jeremy, we talked a little bit about how people haven't been, how surprising it is how many people aren't doing image scanning today. What do you think has prevented people from doing image scanning?
Yeah, it's a good question. I think that we've been kind of waiting to, unfortunately, I think it's unfortunate in the security world that security usually comes after we start to adopt a new technology. So what we've been seeing is, at least over the last couple of years when Anchore was created, was that, okay, we're finally getting folks starting to use container images themselves, and they're starting to play around with what containers actually mean and finally fitting them into CI/CD, and thinking that, okay, maybe that we're taking care of those dependency checks with something like a black duck or a sneak or something. And that's okay, because that's essentially what's contained within the image, right? And for a vast majority of folks, that's true. But then there are all these checks that come into play because Docker images are new artifacts. And there should be new checks to actually uncover all of those pieces I mentioned in terms of users, ports, secrets, anything in the file system itself. So I think it's kind of a bit of both, in that security always feels a little behind in the adoption of new technologies. And then also merely the fact that maybe folks think that they're actually accomplishing all of the checks they need a little bit further left in static analysis of code and then the dependency analysis of the open source libraries.
Yeah, okay, good point, yeah. So another question, for people that have used other open source solutions, so there's Anchore, Anchore open source, then there's something like Claire. How would those compare as open source solutions?
Yeah, it's another good question. It's probably the one we get the most. And I think it's kind of important to note. So when Anchore started and when we were kind of thinking about the idea of what should we do next, Claire was something that was already kind of at least gaining a decent amount of momentum. So what we wanted to do is take some of the things that we learned from the image scanning in Claire and kind of extend some of that functionality, right? So what you kind of see with Claire is that's a really great tool for uncovering the kind of general bill of materials within the image, right? So we're able to immediately see this list of operating system packages and what the vulnerabilities are mapped to particular publicly available data feeds. Well, that's kind of where things stop. And we've kind of been mentioning that, okay, if we're able to, and in addition, we're able to kind of fail based on vulnerability severities and whatnot. But what we wanted to do is say, okay, well, there's a lot more information in there than just that list of packages. There's all of these other, potentially sensitive contents within the image. There's all of these things developers can make mistakes on as they're creating these Docker files and building these images. So we want to make sure that the policy piece of itself is able to act on those particular pieces of data that we're able to analyze. So I would say from the open source perspective, that's probably the biggest one we've seen, and then just kind of a general more enterprisey thing. In terms of scalability, we've just kind of found that scanning, tens of thousands of images daily with Anchore and scaling it out horizontally has been a little bit easier to do than with something like Claire.
Okay, great. And then it looks like we have one final question, time for one final question here, and then we'll go ahead and close. And the question is, when it comes to, here we're looking at a CI/CD pipeline for an application where maybe it's being updated often, and so we're able to catch vulnerabilities. A lot of vulnerabilities that are added to the index are things that are actually not new. They're things that are old that have just been discovered. So how would you say this fits into applications that aren't updated very often, where maybe unless we're rescanning, every day something that's in production, how would we know, how would we catch that that a vulnerability has been discovered in software that you already have deployed?
Sure. So yeah, it's another good question, and I'll kind of tie it into how both or any kind of image scanner we think should work. In that once we scan an image, and let's just say we scanned it 3 months ago, and we have all this analyzed data that contains all of the information we extracted and we saved it in our database that's sitting behind Anchore. That's never going to change. And 3 months ago, we also run that vulnerability application over it and our policy check, and there's no vulnerabilities, and we're good to go. And we push it to our registry, and then we run it. So now we have this container with this ID that's running in production. And then 3 months later, there's a vulnerability that finally gets published and disclosed, and it's available. How do we make decisions based on that? And how do we find it, moreover? So really what we do on the Anchore side is we're constantly pulling down vulnerability data from all of the publicly available feeds. On the enterprise side, there's a third-party feed that we pull from that we've licensed. But in essence, we're pulling this vulnerability data, and you can change it based on kind of your engine deployment if you want it faster than every 6 hours or so. But that's happening automatically. So we have this analyzed data for the image that's running in production sitting in Anchore, and when the new vulnerability gets published and we pull in that data, we also are able to immediately report back on that vulnerability. And that can be set up through something like a webhook notification, right? So Anchore can be configured to send out, okay, there's a new vulnerability for this particular image digest, and send me out a Slack notification. So now we can go find this image digest if we have a container that's running in production.
So it'll basically work as an alert?
Yeah, because once we have this analyzed data saved, that's never going to change. And then as long as we configure our webhooks within Anchore appropriately to say, okay, when there are new vulnerabilities that come out, make sure I at least get alerted on this.
So I could actually use I could have a webhook that went and ran my pipeline again to go ahead and rebuild my images and potentially get them redeployed. So that could be a totally hands-off process depending on the nature of the vulnerability and if the underlying software has been patched. But yeah, very cool. Great. Awesome. Well, with that, we're going to go ahead and bring this to a close. Thanks, everybody, for joining us. And big thanks to Jeremy for sharing his expertise with us and giving us that. So feel free to check out our upcoming events at codefresh.io/events. We've got events coming all the time. And would love for you to come and see our future events. If you have requests for things and topics that you'd like us to cover, let us know, and we would be happy to see if we can get those on the schedule With that, thank you very much and have a lovely day.